Okay, so we're going to start a discussion now about decimals, and so we're going to do a quick recap of what are decimals and how do we kind of do some of the basic mechanics with them before we get into some of the stuff that's slightly more work. Okay, so let's talk about what decimals are. So decimals are basically the same thing as fractions, but we're kind of restricting ourselves to only multiples of 10. So instead of talking about parts of a whole using like 1/3 and 1/5 and 1/7 and we're saying, you know what, we're only going to do things like 1/10 and 1/100th and 1,000th and 1/10,000th, and that's the only way that we're going to be able to express these numbers. And so what you end up finding is that pretty much all of the stuff that we were able to express with thirds and fourths and fifths, we can also turn into decimals. And we're going to talk about how to do that, converting. Okay, but here's a quick recap of what we call place value. Right, so when we're talking about whole numbers like we did in the last unit, we talked about things like the millions place, okay, and the hundred thousands place, 10,000s place, all the way down to the ones place, and then we hit the decimal point. So these all represent whole numbers. So we're actually claiming here that there are 1,342,365 whole pieces, whether they're like little circles or squares or whatever they are. They all represent whole pieces. And then we have this to the right-hand side. We're saying, all right, we're ran out of whole parts. We have all this little extra stuff that doesn't represent one complete whole thing. Okay, and so we in this case have this 0.1427. And so here's what these numbers represent. This represents 1/10 of a whole. This represents 4 1/100ths of a whole. So like if you were to kind of come over and look at this, okay, I'm going to move this over to the side so I got some space. We're kind of saying this is like 1/10, okay, that first decimal place, and then the second one represents 4 out of 100, and then 2 out of 1,000, okay, and then 7, I'm running out of space, out of 10,000. Okay, and so if we add up all these little chunks of like whatever's left after we're done with these million something whole pieces, right, that's what the decimal is, 0.1427. Now obviously we don't want to have to do this with all of our problems, so what we'd say in this case is if I want to name this, we're going to name this in this case 1427 over 10,000. Okay, and that's the kind of the easy way to do it. And you'd see that like if we were to actually do common denominators and add together these pieces, this is what we'd get. Okay, but the idea is that this little 0.1427 represents some chunk of a whole unit, just like a fraction would. Okay, but we're only sticking with multiples of 10 because our number system is all made simple using multiples of 10. So we're going to start off just by saying, if I were to give you something like this and say this number or write it down, describe it using words, what would it look like? So the way we're going to do this is we're going to say the whole number part up to the decimal. So we're going to say 244 decimal point. So we're going to stop, right? 244. And then we can say and then we need to talk about this. And so here's the way this works. We're going to say this is the tenths place. Okay. This is the hundredths place, which I'm just going to use HUND. This is the thousandths place, okay, with a TH. Okay. This is hundredth with a TH, okay? And then this would be 10,000, right? If we were going to the left, it would be ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, right? And that's the way we go to the left. We're doing the same thing to the right, except there's no oneths, right? So we just start at 10th, 100th, 1000th, 10,000th, right? So this is the 10,000ths place. So the way we would describe this in words is, say this number, 126, okay? And since our last decimal place is 10,000ths, okay, it would look like that. So we'd say 244 and 126 10,000ths. Okay, so let's do the second one. Second one is 1,993 and then I'm going to say this number 41,643. Okay, and then we got to figure out like what's the decimal place here. Right, this is 10th, 100th, 1000th, 10,000th, 100,000th. Right, so that would be like this. Okay, a little comma. So I'd read this as 1,993 and 41,643 100,000ths. Okay, which again, that's kind of a mouthful to say, but that's what we're describing here. We're saying some chunk of 100,000 little pieces of a whole, we have 41,643 of those. Right, we're kind of almost halfway to another whole. Okay, so let's move on and talk about how we add these and subtract them. Okay, so to add or subtract numbers that have decimals, we're going to do exactly like we did when we talked about whole numbers in Unit 1. What we did was we just combined like place values, right? So the ones got combined with the ones, the tens got combined with the tens, the hundreds got combined with the hundreds, etc. We're going to do the exact same thing, but on the right-hand side of the decimal, the tenths will be combined with the tenths, hundredths with hundredths, etc. So the easiest way to do this is going to be to stack them and line up all of our place values. And remember, with addition, we can do them in either order. So it's going to be easiest for us to take this and say, let's take the 1,259, and I'd call this 10th, 100th, 1000th, 363 thousandths. Okay? Okay? And then when I'm doing the second problem, I'm going to line up the decimal points, because that's really where the whole numbers end and the fractions begin. So this one's got 245. Okay, on the left, and it's got 0, 1, 2, 7 on the right. So I'm going to do the same thing, 0, 1, 2, 7. Okay, and now I'm going to add these up. Remember, when we're adding, we're going to, anytime we get a number larger than 1, we're going to have to do some carrying. All right, so I'm going to go down the columns now. This is the 10th, 100th, 1000th. This is the 10 thousandths place, and there's an imaginary 0 here if you'd like. 0 plus 7, okay, 3 plus 2. This is addition out here. 3 plus 2, 6 plus 1, 3 plus 0. I'm sorry, let's do that correctly. 3 plus 0. I'm good at math. Okay, 3 plus 0, 3. Okay, decimal point shows us that we're now getting to the ones place. 9 plus 5 is 14, so I'm going to put down the 4, carry the 1. 1 plus 5 is 6. 6 plus 4 is 10. So again, 0 down, 1 up. 1 and 2 is 3. 3 and 2 is 5. And then this 1 doesn't have anything, so I'm just going to bring it down. So we're going to say the sum of 245 and 127 ten thousandths plus 1,259 and 363 thousandths is 1,504 and 3,757 ten thousandths, which you can just say 0.3757. But the idea is that that represents some part of a whole. Okay, so subtracting is the exact same thing, except now we have to do borrowing, right? So subtracting is going to work like we did with whole numbers. So again, let's stack these. It looks like this one we don't have a choice here, so this is an important distinction. With addition, we have what's called the commutative property, and that just means that I'm allowed to switch them, like 2 plus 3 and 3 plus 2. They mean the same thing. Subtraction, I can't. So when we do subtraction, remember we have to do the first number on top. Okay, so 11,293.36. Okay, and then I have this other one on the bottom. It's got a 0.18. Okay, and it goes out 9724. So from the decimal point, 9724. Okay, and so if you notice, this is a 1,000s number. This is a 1,000s number. So I want those to be lined up, and they are. Okay, so let's do some subtraction here. So 6 minus 8, I can't do that without getting into the negatives, so this is where we started doing our borrowing. So if you remember, we said let's borrow, make this a 2 now, and then this becomes 16, okay, minus 8, which is 8, okay, and then 2 minus 1, which is 1. As a side note, if you want to look at these as slightly larger chunks, this is 36, and this is 18, and if you can do 36 minus 18 kind of in your head, you could also do that, right? So just kind of as a side thing if you don't want to have to do borrowing all the time. Okay, well, let's get back. Decimal point comes down. Can't do 3 minus 9, so I'm going to borrow. Okay. 13 minus 9, okay, I can do that. That's a 4. Okay, and then I'm going to say 8 minus 7, I can do that. That's a 1. 2 minus 2, I can do that. That's a 0. And again, this last one, I can say, well, let's get rid of that, make it a 0. Okay, 11 minus 4, 7. Or you could have just looked at this as 11 minus 4, right, once you get to the end. So subtracting, I have 7,014.18, and that's going to be my answer. Okay. So the last thing we're going to talk about, again, this is kind of one of those slightly more straightforward things because it's just like whole numbers. Okay, we're going to talk about rounding. So rounding decimals is just like rounding whole numbers. You're going to look, if I ask you to round to the nearest tenth, you're going to look at that decimal place. Okay, you're going to keep that decimal place, and then you're going to look one to the right, the next one, the first one that you're getting rid of. If it's if it's a number between 0 and 4, okay, you're going to leave it alone. Okay, if it's between 5 and 9, you're going to do a +1 on the place that you're keeping. Okay, so if I'm looking at what is 1279.814 to the nearest tenth, well, I'd like to keep the tenths place. Okay, the number to the right is a 1. That means I'm going to leave that tenths place alone. I'm not going to increase it. So I'm going to say that the rounded version is 1279.8. That is rounded to the nearest tenth. Right, tenth place stayed behind. Okay. Next problem, to the nearest thousandth, and again the th at the end is telling me that I'm doing the decimal side, not the whole number side. So I'm going to say in this case that would be thousandth would be, this is tenth, hundredth, thousandth. So I want to keep this place, okay, which means I'm going to look to the right. Okay, that one's again a number between 0 and 4, so I'm going to leave that 5 alone. I'm not going to increase it. So 18794.015, there's the thousands place, okay, and I'm not going to do anything to increase it because 3 was so small. Okay, let's talk about the nearest hundredths place. Okay, actually let's do one more of these before I talk about this one. I'm going to do this one also now to the 10 thousandths place. If I did one to the 10 thousandths place, okay, it would be 18,794. Well, 10 thousandths place is this one, so I want to keep this place. I'm going to look to the right. That's now a number between 5 and 9. That means plus 1. So I'm going to increase this 10 thousandths place up to a 4 when I rewrite it. Okay, so 0, 1, 5, 4. That's the 10 thousandths place, right? So just to show you an example of one where I kept the place and another one where I did increase it because the place to the right was slightly larger. Okay, so let's talk about this one last example where we end up with kind of a unique case. This says round to the nearest hundredth. So again, the th at the end is my indication that I'm talking about decimals. Tenth, hundredth. This is the place I'd like to keep. Okay, so everything to the right of this is going to get chopped off. And my rule says if the number to the right is between 5 and 9, increase by 1. Okay, so I'm going to say 149,125.9. Okay, well, I'd like to increase this by 1. That's going to make it a 10. So I'm going to have to carry a 1. This is now going to become a 10. I'm going to have to carry a 1. This is actually going to become a 6, right? So by rounding, I actually ended up completing a whole. So let me rewrite that so it looks like legible writing. 149,126. And I'm going to write the 0, 0 because it asked me to keep to the nearest hundredth, right? So I'm going to show them that there is actually nothing in those places, right? So 149,126.00 is rounded to the nearest hundredth.